Homework busy? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
Hi, everybody. So this question is saying determine the wavelength of the second Balmer line and the wavelength of the second Lyman line and the wavelength of the third Balmer line. So here we were given n equals 4 and 2 n equals 2, okay? And we have this equation for the wavelength equals Planck's constant. And here we have E4 minus E2. Okay. Oops. There we go. And to find that, we need to use this equation here to find the ends, okay? To find the energy. So we got 13.6 divided by n squared EV, okay? So here we have E4 equals 13 negative 0.6 divided by 4 squared EV. And that's going to give you negative 0.85. Let me write that a little bit nicer. 0.85 EV. Then we have E2, which is negative 13.6 times 2 squared EV. There we go. And this is going to give us negative 3.40 EV. Now, all we have to do is plug it into this equation. And this is going to be, so HC is actually going to equal 1.24 times 10 to the third EV over nanometers. And you should be able to get that constant here because it's a constant. And that should be given in your textbook, okay? So we get negative 0.85 EV minus negative 3.4 EV, okay? And that's going to give you 486 nanometers for A, okay? Now let's do B. And B, we have the n equals 3, and we have n equals 1. So it's the 3 to that, okay? And we're just going to do this again. So we have negative 13.6 divided by 3 squared equals, oh, don't forget the EV, like I was about to. There we go. Okay, and that's going to be negative 1.51 EV. And then E1 is going to be negative 13.6 EV1. And that is going to be negative 13.6 EV. And now we're going to plug it into our lambda equation, and we have 1.24 times 10 to the third EV times nanometers divided by negative 1.51 EV minus negative 13.6 EV, okay? And that's going to give you 103 nanometers. Now, for C, we were given n equals 5, 2, n equals 2, okay? And we're going to have to do the exact same thing we did a second ago. So we have E equals the fifth. So let me make that a little nicer. There we go, negative 13.6 EV divided by 5 squared, or 25, equals 0, negative 0.54 EV. It's negative here. And we don't have to do 2 because we already did 2. So we're going to just skip doing this 2 because we already did 2 in the first prop for part A, okay? So it's going to be lambda equals 1.24 times 10 to the third EV times nanometers. Okay. And we got negative 0.54 EV minus, and for the first problem, we had negative 3.40 EV. Okay. And this is going to give you 434 nanometers. Okay. And that is your answer, guys. Thank you.